Life functions by an orchestrated interaction of biomolecules. Can we develop methods to listen to them in order to understand how they talk to each other? I'm Ulrich Rant. I'm professor for physical chemistry and the director of the Kurt Schwabe Institute. A lot of the work that we do has to do with animal welfare and healthcare. So we developed sensored and analytical technologies to measure interactions between small molecules, ions, DNA, RNA, proteins, up to whole cells. The main theme was always it has to add value to a user, and it has to be robust and it has to work well. We're currently working a lot on cancer applications, but we're also working on processes to improve technologies for a cleaner and sustainable industry. So our vision is to develop sensors that can be used every day. So we're always trying to improve people's lives by coming up with new ways to prevent disease. I came to TU Dresden recently after a stint in industry where we developed analytical systems, instruments for drug discovery. So I guess a scientific career doesn't have to be a one-way street. I always like to see things not only as fundamental research, but actually translate them to a real-world application. If you want to develop an application-ready sensor or biosensor, interdisciplinarity is key. So you'll need aspects of physics, chemistry, medicine, molecular biology, also prototyping and electrical engineering. And this all has to come together in order to make a good integrated sensor system. So this is the environment that I found at TU Dresden and in the greater Dresden research community and also in Saxony.